application of data science in geosciences. So like I said initially, there are different geoscience sub-disciplines or fields you can look at. So you could as a geoscientist, so you're graduating from school now, you can decide to go into climate and metrology. And some of the courses that relates to this you do in school is sequence stratigraphy, because climate, like you said, the present is the key to the past. And looking at, so if you want to see how sea level, because I remember sequence stratigraphy has to do with rise and fall in sea level, and this is how climate is being studied. So if you want, so you can choose to go into climate and meteorology. You could also go into environmental and resource management. I think there's something environmental geology. You have hydrology. So this is what relates to this part. So you want to understand the environment, how the environment is impacted, and how you can mitigate some of these environmental disasters, water management, and the rest of it. You could also think of going into mining and mineral exploration. So you have I think it's petrology, and I think there are lots of courses that relates to this. Then we also talk about exploration of energy resources, where you look at your oil, you look at gas, you look at geothermal resources, carbon capture and storage. All this relates to exploration of energy resources. So I'll be going into these different sub-disciplines one after the other and showing you some actual projects you can carry out with this. So the first is climate and metrology. So the Earth's climate system is complex and influenced by numerous factors. Data science plays a crucial role in climate modeling by assimilating vast amounts of historic climate data to create predictive models, and these models can help us project future climate scenarios, study temperature trends, analyze sea level rise and fall. So you could also look at your paleoclimate research, where you look at your core data, because most of your rocks stores a huge amount of information on how the Earth was and the condition the Earth was when those rocks were being formed. So you can get this information from your core data, from your well log data, and ocean sediment data. So you could carry out paleoclimate research using these different data. Then you could also measure climate change using remote sensing data and how it impacts the climate. So an example of some projects you want to do, and that's been done before now, is machine learning to predict the initiation of thunderstorm using meteorologic data. And you could also run machine learning models to process satellite data to track so this is a project that has been done to track the Arctic ice melt. So these are some of the projects you can do even as a final year student, so that you are already getting a feel of what's being done in the industry. And some people might ask, okay, how do we get this data? There are lots of data available online. So one of them I can freely tell you is Google Dataset. So if you just type on your computer Google Dataset, you can come up with different data sets across different regions and different disciplines. So you could just type, okay, if I want to do something on climate, just type climate under the Google Dataset, and you see a lot of data that you can use to carry out projects relating to climate and meteorology. The next we'll be talking about is remote sensing. Satellite imagery and remote sensing data provides a view on our Earth's planet. So you can so you talk about satellite imagery, so you can take out satellite image and study this satellite image to see how things has changed. So for example, you can take let's say satellite image of a particular region in the last 10 years, and you can use your data science to study this data and see how it's been changed from year to year, and see how that impacts the general region, how things has changed over time. You can from satellite images, you can look at how, for example, a vegetation pattern has changed over time. Then we can go over to minerals and mining. So with also with data sciences in the minerals and mining sector, you can identify patterns in your data set to know areas with high concentration of the mineral you are interested in, or areas where it's safe to mine these minerals. Yeah, and you can use this to identify new areas of opportunities, because it comes up with patterns. So if you get, for example, if you have a region where you have high concentration of minerals, you're able to identify the pattern and trend in that mineral. So you can take that pattern and trend and use it to predict on a different area where you see similar patterns. You can be an indication of a mineral deposit in that area. Okay, you can also use it to get you use data science to get a better understanding of your subsurface mineral deposit. Case study example that's been done using machine learning to predict for copper grades, so the grade of copper in different mine, and also used machine learning to predict the tailings for in dams. So when you in the mining industry, when you do open pit mining, those wastes are called tailings, and they are not good for the environment. So with AI and data science, you can predict the impact of these tailings and the potential risk to the environment. Okay, then this is a pyramid for energy exploration. So if you want to go into the oil and gas industry, I don't know if you'd have seen this typical pyramid for exploration through to production. So you have exploration phase is a process where the phase where you try to source for this mineral, or this, let's say oil and gas, for example. What are the areas where you can identify oil and gas? And you look at appraisal. You want to look at what's the quantity of oil and gas in a particular field. Then you go into drilling. When you drill, you want to start managing your reservoir. When you want to produce, then you go into full production of this oil and gas. So yeah, I want to highlight some of the data science role at these different levels or stages or life cycle in a typical oil and gas life cycle. Okay, so the first is exploration. So with data science, you can look at surface geology evaluation. So before you go into a new area, you want to look at the surface geology using satellite imageries. And like I said initially, with your data science, you can use data science to study your satellite images for changes. Then you could also look at subsurface when you look at basin evaluation, petroleum system and reservoir modeling. Data science and AI can help you within this. Then you want to look at delineating reservoir structure. This relates to you mapping your seismic. I don't know if you've done seismic interpretation yet. So the idea of seismic interpretation is to create a structural framework of your reservoir. And with data science and AI, advanced AI, you can train models to help you identify faults and map out your structure of your reservoir, basically using data science fully. You can also do reservoir characterization. This involves using well logs to interpret lithologies and to interpret facies and stratigraphy within your data. Your data science can also help you in core image analysis. Where you have your core images, you could use trained models that can help you tell you this is sand, this is shale, this is a good reservoir, this is not a good reservoir. And also when you have core photographs, train sections, you could also use train AI to identify the different minerals present within your thin section. And also AI can also help you to tell you where it's best to drill. So you've gone through all the process of exploration and you've been able to identify that okay, there is oil and gas here. Training models can help you identify okay, this is the best position or the most optimal place to drill your well. Then moving down to drilling, there's a lot of technological advancement that can tell you the best position to drill, because if you're in the industry, a geologist can tell you this is the best position to drill for this well, but when you bring it back to the practicality of it, a drilling engineer will tell you that you can't drill here because of natural hazard. So you have to look for that balance. A geology well position, a petroleum engineer's well point, and also a drilling engineer. So with AI, you can kind of collapse this complexity of these different fields, because it's you are bringing these different data into the same time and space and give you the best position to drill to get the most from your hydrocarbon resource, and also the best position that you can drill safely and efficiently. Also, there's a lot of techniques that you can do directional drilling and interact with your subsurface while drilling. Then we go about reservoir management. So there are lots of models where people have trained machine learning models and data science techniques where you can manage your reservoirs, because when you do reservoir management, you run lots of simulations, and these simulations are often time consuming. So but you can automate or speed up this process using AI and its advanced technology, reducing costs and time. Then during production, AI can also help you by identifying areas of inefficiency. So while you're drilling, while you're producing, you can train models because while you're drilling, you're collecting data from these different ways. Like data is being collected 24/7. So analyzing this data can tell you areas or wells where they are performing poorly as regards to the others, and can also use it for predictive maintenance. So rather than waiting for machines, because most of the time when you produce, you are installing facilities that can help you. It could be your flow station, it could be your flow line. So rather than waiting for these equipment to fail, you can predict when they will fail, so that you are proactive and not waiting for them to fail.